This lesson is on dilations and similarity in the coordinate plane. Our vocabulary for today is dilation and scale factor. A dilation is a transformation that changes the size of a figure but not its shape. The preimage and the image are always similar. A scale factor describes how much the figure is enlarged or reduced. For a dilation with scale factor k, you can find the image of a point by multiplying each coordinate by k. So the point AB would go to the point k times A, k times B. If the scale factor of a dilation is greater than 1, then it's an enlargement. If the scale factor is less than 1, it's a reduction. We should be pretty familiar with this by now with A in our other transformations that we did. If A was greater than 1, it was a stretch. A less than 1 was a compression. Same type of idea. Also, if it was greater than 1 for exponentials, it was growth, less than 1 decay. So same type of thing. Here we have if it's bigger than 1 enlargement, less than 1 is a reduction. Here we want to draw the border of a photo after a dilation with scale factor 5/2. We go ahead and multiply all of the vertices of the photo, A at 0, 0, B at 0, 4, C at 3, 4, and D at 3, 0, by the factor 5/2. If we multiply all of those, for A, we get 0, 0. 0 times 5/2 is 0. For B, we get 0, 10. C, 7.5, 10. And for D, we get 7.50. So we have A prime, B prime, C prime, and D prime. Now we can plot those to find our... And this would be our new rectangle here. So we had the original rectangle on the previous page, and now we have our new rectangle with the horse. And it's now going from 0 to 7.5 and 0 to 10. Finding the coordinates of similar triangles works in a similar fashion. So we have that triangle TUO is similar to triangle RSO, and we want to find the coordinates of U and the scale factor. Since triangle TUO is similar to RSO, RO to TO is equal to OY to OU. We substitute 12 for RO, and 9 for TO, and 16 for OY. Using a cross product, or cross multiplying, we get 12 OU is equal to 144. And then divide both sides by 12 to get 12 as OU. U lies on the y-axis, so its x-coordinate is 0, and since OU is 12, the y-coordinate is 12. So the coordinates of U are 0, 12. 0, 16 needs to be multiplied by 3/4 to get 0, 12. So the scale factor is 3/4. Let's look at another example. Now we have PMQ for our big triangle and MON for our smaller triangle, and we want to find the coordinates of n and the scale factor. These triangles are similar, so first thing we're going to do is put our proportionality constants here. We have OM over OP equals ON over OQ. OM was 10, OP is 15, and OQ is 30. So we plug those in, cross multiply, and find that ON is equal to 20. N lies on the y-axis, so the x-coordinate is 0, and the y-coordinate is negative 20 because it's going down, not up. So in order to get from 0, negative 30 to 0, negative 20, we must multiply by 2/3. So the scale factor is 2/3. Let's prove that a triangle is similar to another triangle. We have EHJ for one triangle and EFJ for the other. So we plot the points and draw the triangles. Then we use the distance formula to find the side lengths for EH, EJ, EF, and EG. Go ahead and pause the video here if you need to. I'm going to continue on, but make sure that you try this out on your own to make sure that you understand it. And now we need to find the similarity ratio. So EH to EF from the previous slide, the distances are 2 radical 17 to radical 17, which is the same as 2 to 1 because this radical 17's cancel. 2 over 1 is 2. EJ to EF is going to be 8 radical 2 over 4 radical 2, which reduces to 4/2. 8 over 4 is the same as 2. so they're both equal to 2. So they are similar triangles because the triangles or the angles are all congruent, and therefore they have the same proportionality constant, therefore they are congruent triangles. Let's try another proving RST. So here's another picture where we've plotted the points and drawn the triangle. Again, we use the distance formula, and again, go ahead and try to pause the video before you see these and try it on your own to see if you can figure them out. RS is radical 2, RU is 3 radical 2, RT is square root of 5, and RV is 3 radical 5. The next step is to find the similarity ratio. RS to RU is radical 2 over 3 radical 2, which reduces to 1/3. RT to RV is radical 5 over 3 radical 5, which is also 1/3. In the first one, the radical 2's cancel, and the second one, radical 5's cancel. Be careful you don't reduce these to 3. The 1 is still on top, the 3 is in the denominator and cannot move up to the numerator. Since all of the angles are congruent and we have two sides that are in proportion, the triangles are similar. Let's go ahead and graph the image of ABC after the dilation with scale factor 2/3 and verify that they're similar. We want to multiply each coordinate by 2/3 to find the coordinates of the vertices A', B', C'. So we have A, 0, 3, and that changes to 0, 2. 3, 6 moves to 2, 4, and 6, 0 moves to 4, 0. So we graph A', B', C' in red. That's our new triangle, and we want to prove that these are similar. We use the distance formula to find side lengths, and again, try these on your own, see if you can prove it. AB is 3 radical 2, A', B' is 2 radical 2, BC is 3 radical 5, B', C' is 2 radical 5, AC is 3 radical 5, and A', C' is 2 radical 5. Now we can put all of these into ratios. A', B' to AB is 2 radical 2 over 3 radical 2, which reduces to 2/3. B', C' over BC, same thing. A', C' over AC, same thing. We get 2/3 for all of them. Since all three sides are proportional, triangle ABC is similar to A', B', C'. Here's your lesson quiz. Go ahead and try some of these out, see if you can figure out the dilations and do some of the proofs, and we'll talk about them tomorrow if you have any questions, and we'll do some more practice with them as well as applications.